Hello guys, good afternoon. So it's me Oscar once again from Elite 3D Homes. So this video is basically going to be about the material, the building material for the 3D printed houses. Now we have to make a structure. For example, we have these materials that, like for example, the wire gauze. Usually when we build houses, maybe concrete houses, concrete flooring, like we have these wire gauze, and we have these rods, the rods that actually goes to make the structure be a very straight one, right? And but with the 3D printed technology, actually this has been changed. Now, if you've watched some of my videos, like if you go to my channel, you're going to see some videos that I made where I explained a lot about the 3D printed houses. I'm sorry for the long videos in the period times, but then it's just basically to explain a whole lot about a real lifetime 3D printed house, right? So if you watch those videos and understand that now there are some parts in the videos where I shot which have these nettings, like that looks like these gauze that are used to make the building strong, to basically whatever structure, right, to make it a strong structure so it doesn't break or crack, or maybe to support the structure of whatever thing you're building. Now, but the thing I didn't know actually was those were plastic glass. So basically in this 3D printing, in this 3D house printing technology, so we have plastic glass. Now, I took some samples. For example, here, I showed it in some of the videos. So this is just plastic glass. If you look at it, you take a good look at it, it looks like a rod, just that it's different color, but it's somewhat it's the color is somewhat greenish white, right? And here, these are the kind of netted gauze, right? We actually fix them when building structures, like laying them above, and they help hold. All these are plastic glass, like you can see how flexible is it. Now in this video, basically I'm just gonna show us, we're gonna see how strong is this material, because I actually thought that, I mean, look, it's too flexible. Now I'm not gonna flex it so much so it doesn't break and then the pieces doesn't run into my eye, but I actually kept it this way for some time now. Since I took it, I thought that it was gonna deform over time, like it's kind of a little bit bending, but it didn't deform. I took these out and it was just still straight. Okay, so but now I'm gonna show how strong these materials are, because they are actually less expensive and they are good. Why do they use these materials? Because the house expands and contracts even after we finish printing, maybe depending on temperatures, especially those that live in countries where we have high temperatures, low temperatures. So during this, these can expand and contract while doing its work, like holding the structure, not falling apart, right? And now I really want to see, I want to break this. Let's get to it. So for this experiment, basically I just need 2 set of pliers or glasses, just for safety measures, and then the gloves, and of course we have the plastic glass I'll be using. So the main aim, basically, I want to see how strong this material is. So with everything, with the safety measure on, now I'm gonna try to break. Now I'll start from this, which I think is really soft. Remember, I told you guys it's soft. Now I'm gonna start with this first. Here, I'm gonna try to break this because I want to see. I really have these doubts thinking, how is this gonna hold the building? I mean, you know how many tons and the pressure that is put on the building? How is it going to hold the building? Okay, I'll try to break this piece. Let's see. Okay, look at that. That actually came out. Like, it broke. It's just like some fiber or something like that. But I mean, you saw the length it took. Yeah, you can see it. So it broke. That's just kind of close view on that. And what you can see, I have to take it a little bit far. Oh wow, that's great. It broke. Now, well, that's the piece there. So yeah, but it took some hard energy to break. Now I'm gonna try it the second time. I thought it was just gonna snap like with an exploding sound, but it didn't snap. It didn't snap, it just broke. Now I'm gonna try a third one so as to make sure I got a nice view of it. Here. And it didn't snap. Like, it snapped, but it didn't break, like shattering pieces everywhere. Wow. Okay. Just take the safety goggles off. Now, well, that's it. Now, yeah, look at it. Now, this time, I'm gonna try to snap it this way. Like, let's see. Oh, look. That's it. Look, it just broke on these sides. On this part are just weak. Just broke on this part. Okay, now there's one part. Let me get out this piece. And yeah, I'm gonna try to snap it this way. If that's gonna allow me. I'll put this out of the way so we can see how it snaps. Now I'm just applying how many pounds of force to it. I just want you guys to see the angle. And then, come on, it's not breaking on this part. It seems so hard. Okay, I'm gonna try a different way. I'm trying to make sure so that this part doesn't stab into my skin. I just really want to rip it. Okay, I'll try. I mean, just look at that. Okay, one part got broken. And come on, what about the other part? Okay. Woof. I mean, that's a whole lot of energy, and just what came up was this part. Okay, now, that's how strong this is. So definitely, I think it's worth it. Like, I mean, I don't know how many pounds of force I applied to this, but it's worth it. Like, this part snapped, and this part got broken, but this other part was just there. I mean, it went all that way. So here you have it. So I guess we can trust this is gonna be strong enough to hold the structure, whatever structure it is that we're putting out there. Now the next is this. I'm gonna try to snap this maybe with my fingers. Okay, let's try this first with a plier. Pull this apart so we see it here. Great, let's try this with a plier. And it's so... Okay, I got it. Well, that's because I applied it with a plier. Okay, now let's see here. If we see right close to it. It didn't break completely. Okay, this part broke out. But then the other parts, we just like, you know, it proved some form of its elasticity since it's plastic glass, right? Here, look at it. Look at it. Okay. Now, wow, that's not coming out real But yeah, one can trust these materials to build a house or structure. I'm gonna try to snap it from between. Let's see. And it's difficult. Okay, I'm applying some, and it just can't snap. So I mean, it's really, and it's back straight. Just look at that, like it didn't bend. It's just back straight. It didn't deform. So one could actually rely on this. I mean, this is a rod. It's like a rod. It just, we can see the thickness, right? You can see the thickness, because I had a doubt that this is not gonna hold the structure to some point. I never snapped it for the first time. This is my first time doing it, but I'm like, I'll do it with you guys watching the camera and seeing everything. Because yeah, I was gonna buy this, and it's less expensive than the usual rod, the building rod, right? It's less expensive, has good elasticity. Basically with these materials, with the rod materials actually, they don't have good elasticity, like not like plastic, right? This plastic glass has got more flexible, and it could expand maybe in heat or whatever, and also during contraction it could hold that. But with a rod, basically it's just going, it's due to the fact that it doesn't, like, just imagine the rod inside the concrete, right? It's two different materials, and basically the rod, because they have different expanding, like the rod is not so flexible like that with the concrete. So sometimes that's where we notice some cracks on the walls and stuff like that, or maybe on a pillar there's a crack on the pillar and stuff like that, because of these expansion, whatever, and expansion and contraction of materials. So but with this, with a plastic glass, I guess it's more reliable, because yeah, when it starts expanding in the mixture, like with the sand cement mixture, whatever it is, I think this can hold that temperature. It can expand or contrast together with that, so which makes it a more suitable and reliable material for building. Okay, thank you very much.